Welcome, everyone. We are excited to have you join us this morning. On today's webinar, we'll be discussing how MQTT significantly enables smart mobility by facilitating efficient and reliable communication between various components of a smart mobility ecosystem. I'd like to begin by introducing our presenters. Today, we are joined by my coworkers, Josh Eastburn and Ernest Russell. Josh is our Director of Technical Marketing here at EMQ. After more than a decade as a control systems integrator, automation engineer, project manager, and marketer, before starting his career in tech marketing, Josh studied computer science at Cal Poly and worked on industrial automation projects supporting process equipment for semiconductor giants like Intel, TSMC, and Samsung, as well as applications in the petrochemical, food and beverage, and life science industries. As a marketer, his work is focused on educating the engineering community about MQTT and other technologies for IoT. Ernest Russell is our technical content manager here at EMQ, working in our marketing department. He brings over a decade of experience in information technology and broadcast engineering, supporting some of the largest media companies in the world, including CNN, Turner, and Fox. Ernest has always been passionate about learning and writing, earning a master's degree in networking and telecom management. As a technical content manager, Ernest is focused on knowledge sharing and best practices for MQTT and IoT. So just want to go over a few housekeeping notes before we begin. Please note this webinar is being recorded. The webinar will last approximately 60 minutes, 45 minutes of presentation, and 15 minutes allotted for Q&A. Feel free to submit your questions within the Q&A tab, and we will address them at the end of the presentation. Wanted to go ahead and give you a brief overview of what the agenda is for today. Whoops, a little bit of a lag there. So with that, please go ahead and Josh, the floor will be yours.
That little trick work. Okay. We'll find out. Hey, everybody, thanks for joining. I'm Josh Eastburn. I'm going to see if I can control this presentation. There we go. I think that's working. Okay, so we're talking about smart mobility today. And probably if you're here, you already work in this space. Oh, see, there you go. That's that double click lag. Let's try again. Go back one. No, not working for me. Would you mind? There we go. Back. Sorry, everybody. We're figuring this out. There we go. That's where I wanted to be. Hopefully this is where you wanted to be, because we're talking about smart mobility. So I wanted to define some terminology up front, whether you are working in the smart mobility space or not. That way we're on the same page. When we talk about smart mobility, what we're really talking about is integrated transportation, right? Different modes of transportation, different environments for transportation, generally within city environments is kind of what we're talking about. But certainly across different systems that are now used to manage traffic and transportation within those environments. And I think we're also considering the different stakeholders, the different populations that rely on these modes of transportation to get around and to live their lives. So what's the purpose of that? Trying to improve access to those systems, right? Make sure everybody can use all of that transportation, but that they can also do it more efficiently and have a better experience doing it. And I think everyone would probably acknowledge that, certainly environmental impact is a big part of smart mobility, right? It's a necessity. It's a daily necessity for most of us, even those of us who are working from home. Transportation is a big deal. But we also know that it has a big impact on the environment, and we want this whole thing to work better. So that's the goal here. Obviously, there are some challenges involved in getting there. I kind of broke them down into 4 big buckets for you. Talking about integrated transportation at the scale that we're considering today certainly has a big investment, right? There's a big financial impact here, and we're gonna see that at all different levels, right? Federal, state, local governments, private corporations are all going to get involved in this in different aspects. whether they are users or regulators or suppliers. And they're going to have particular goals and maybe constraints. If you are the solution provider, right, they're going to have goals that you need to meet. That leads to and relates to, I guess I should say, operational considerations. Because of the scope of these systems, we're looking at different agencies needing to work together, maybe to make decisions, but certainly to share information, right? Data is moving between systems that are currently segregated, right? In order to make this all work, this data needs to come together. They're going to have to decide how to do that. There's going to be lots of meetings held to make those decisions. And that relates, I think, even to a bigger scope, which is like the societal impact that smart mobility systems could have. There's certainly going to be regulatory decisions that need to be made. Laws passed, things like data privacy and security. We're already seeing that on the connected vehicle services side. This kind of takes that to, I think, an even bigger level, right? When you start getting national and state governments potentially involved in regulating these systems and making sure that people's data is being used appropriately, they're being protected, and that they're safe. When we start talking about this level of integration of vehicle data, there could be some concerns that flow out of that. And so the technical bucket kind of underlies or maybe better said, connects to all of these different things, right? Each of these different groups, these stakeholder groups, will have some concerns that the technical implementation will need to satisfy. And we're talking about one aspect of the technology today, but we'll touch on how it relates to these different areas. And there are also some strictly technical concerns, right? Like the system needs to scale up to the appropriate size for the systems that we're talking about. It needs to be reliable. It needs to be maintainable. It needs to be interoperable with all of these different systems that are involved. The specific technology that we're talking about today, hopefully the reason that you came to this broadcast, is MQTT. If you're not familiar with MQTT, I highly suggest you go back and look at some of our previous webinars where we do a deep dive into MQTT and a related technology called Quick. This will be kind of more of a focusing on the applications of MQTT rather than going deeper into the technology. But to kind of recap it quickly for you, MQTT stands for, or used to stand for, Message Queuing Telemetry Transport. Now it's just MQTT, but the important part of that is the telemetry transport part, right? As HTTP is used to move certain kinds of data over the internet, MQTT was designed to move a different kind of data, specifically device telemetry data, originally designed by IBM to solve this problem of having a lot of devices out, distributed and needing to communicate with them in pretty close to real time, right? This was back in the 90s, designed for process control, but very demanding, right? Requiring real-time performance. And at the time, internet was not really quite a thing yet, but using TCP as a transport layer and trying to figure out how do we get improved performance for these devices that are spread around, that don't have a lot of processing power, and where we can't really rely on the network connection. So now, fast forward all of these years, that same protocol has found a great fit in the Internet of Things because it fits that same profile. Lots of distributed devices, not real heavy on resources, and sometimes in sort of unreliable network circumstances. And hopefully you can see how that applies to transportation already. But if not, I will try to illuminate that. Why are we talking about this? If you have no idea who EMQ is and you just ended up here by happy accident, we are the designers, developers, supporters of the world's largest open source MQTT broker, which is MQTT terminology for a server, right? But that's the function that an MQTT server provides in an IoT application. It sits in the middle and it brokers traffic, right? Specifically today, we're also introducing a product called EMQX Edge Cloud Platform. By introducing, I mean, we're going to touch on it and how it applies to this. This isn't really a product deep dive either, but so that you know where we're coming from, EMQX is our MQTT platform, and ECP builds on top of that specifically for these types of applications where you're looking at very large scale, multi-cluster type of infrastructures. And when I say multi-cluster, what we're talking about in this case is potentially, multiple buildings. Maybe each building has a broker. Maybe each city has a broker. Certainly we support applications now where we have EMQX clusters distributed across multiple regions, and they all need to work together, or they may be part of the same system managed by the same group. And ECP is designed to make that level of management and integration a lot easier to do. So that's where we're coming from. That's our perspective on MQTT and kind of our pedigree. Why do we think it applies to smart mobility? Or actually, let me take a step back from that. Where does it fit in? If you imagine the whole of a smart mobility type infrastructure, which is going to have so many different parts and components, we're not talking about the hardware, we're talking specifically about the software. And MQTT specifically facilitates the movement of telemetry data from devices at the edge, which could be vehicles, it could be cameras operating out in a city environment, could be sensors, let's say it could be a sensor on a gate in a parking garage, right? Is that gate open or is it closed? Is a traffic light on? Is it off? What color is it right now? So many different things you could imagine in a city environment related to traffic control, transportation, certainly things like charging infrastructure, parking garages, all of those things relating to how vehicles move around the city environment. They're generating tons of data. It's a particular kind, right? They're not generating documents. Some of those things do maybe have files associated with them or images that they might be generating. And MQTT can be used for those things also, but primarily it's used for that near real-time small payload data that just says, this is how fast I'm moving. This is my location in the world, right? Geo coordinates. This is the state I'm in, open or closed, on or off. So many different devices in a city generate that kind of data. And that's really why, as an IoT company, kind of our focus, that's why we're talking about smart mobility, because it fits that profile really well. And then, of course, MQTT in particular is great for this type of application because it was designed for scale and for reliability. In particular, when you have vehicles moving around a city environment, switching between different types of networks, they're going to have a particular kind of challenge that they need to deal with in communication, right? That'll create a certain level of unreliability. You'll need to be prepared to deal with that. And MQTT was designed to solve that same problem as well. So some of the benefits of using MQTT to fit into this particular part of your smart mobility infrastructure. So now that it has this, I guess, 50 years pedigree, not quite, we're getting there, but it's got a pretty good history at this point and has been broadly adopted for IoT applications. So you'll find that it's already integrated with pretty much any cloud platform that you're using. If you decide to use MQTT, you'll find compatible services, right? So there's already a high degree of interoperability. So again, I can't imagine that there's a situation where you're building a large scale infrastructure like this where you're not going to be leveraging cloud resources in some case, or in some way. But in any case, however you use MQTT, you'll find a broad array of tools and a lot of support for it. But the protocol itself, as I've mentioned a couple of times, was designed to fit into this type of application, this sort of niche, where your resources available at the edge may not be very large, right? So MQTT solves for that by being a very lightweight protocol. And it does that in a few different ways. It's lightweight both in terms of the memory, the processing power that it requires from an edge client. It's also got a small footprint on the wire, right? So the payload format is very stripped down compared to a protocol like HTTP. And Ernest is going to touch on that a little bit later on. And because it was designed for unreliable networks, it has some native fault tolerance mechanisms built into it. You're able to control quality of service. You're able to designate message retention capabilities or session retention capabilities, assuming or expecting that clients are going to come in and out of connectivity, right? As opposed to some other options that require maybe a constant or a synchronized point-to-point connection in order to communicate. That is not a constraint of MQTT, or it was designed around that or without that expectation. And then because it was designed for real-time systems, real-time performance is what people look to MQTT for, right? And we're talking below 1 second, certainly, and many cases below 100 milliseconds or even less than that. Those are applications that we have seen that we have supported. So those are very very reliable kinds of numbers. And in terms of scale, the latest versions of EMQX support, we have benchmarked them, I should say, at 100 million connections, which is way out there for present day applications. But as we start talking about smart mobility and these sorts of real world applications that people are working on that require many, many systems, right? This is a system of systems that all need to be connected together. Those numbers stop being fantastical, and they're within the realm of possibility, right? It's kind of on the horizon right now for most of us, but they're becoming real very quick. And again, that's what MQTT was designed to support. And we've seen that already. With that, I mentioned Ernest was going to dive into a little more the comparison between MQTT and other protocols, and what makes them a good fit or not for smart mobility in particular. So I'll hand it over to you, Ernest.
Thank you, Josh. Always a pleasure to join you. And one of the questions that I get most at events, at trade shows, and even in internal meetings is what are some alternatives to MQTT? And so I'll touch on that a bit before we go into some use cases. And so first, I'll mention some of the logos you see here, like for instance, Zigbee, right, which is a popular protocol for home automation. So definitely worth the mention here in the context of smart mobility. It doesn't fit directly into the picture right now. And also LoRa, right, which is long range wireless networking. And LoRa it typically reaches further than Wi-Fi, so it is a great wireless option. But many times I see that used more in conjunction with MQTT versus a replacement, right? So it's a great way to carry that MQTT data over wireless network. And so the most familiar protocol the protocol you're most familiar with is probably HTTP, which was originally designed to deliver text or text documents, and it is very good at that. The advantage of HTTP, one of the advantages is that it has had a very well adoption, and so there's a lot of development against it. There are a lot of developers for HTTP, but it was not designed and not as effective natively within IoT devices and IoT networking. And that's where really MQTT starts to shine. And these are devices that may not have servers, computers inside of them. As Josh mentioned, these are devices with a very small code footprint, and as well as maybe limited network access, right? So maybe the network drops and comes back. Maybe it's just a low bandwidth network, but MQTT really shines over those types of networks. MQTT is also a bidirectional protocol. So once we establish an initial connection, then we have bidirectional communication versus usually HTTP requests are usually client initiated. So again, MQTT shines especially in the IoT world. And so similar, the next protocol I'll cover is CoAP. Similar to HTTP, CoAP uses GET, POST, PUT, and DELETE request to move information. And unlike HTTP, it sends that information in binary, which instead of text is it's a smaller footprint. And so again, it's more suited for IoT devices, IoT networks. CoAP, it supports it. It actually uses UDP, so it does support two-way communication and multicast, which multicast is something HTTP doesn't work very well in that environment. And it CoAP has similar to MQTT. It has a way to subscribe or what they call observe observe changes in the REST messages, and so you can use that to alarm or to get information back when the state changes. So CoAP, we have seen IoT devices use that protocol pretty often. I would say really, and especially with EMQ, we believe that MQTT is really the underlying transport that's going to take us forward into. And that's why we said we're paving the way for smart cities, for smart mobility, because we believe MQTT will really be that protocol that allows us to continue to build solutions that work together. And so finally, I'll mention LWM2M. Which was proposed by the Open Mobile Alliance in 2013. And it actually uses CoAP for its communication protocol. So very, very similar in that way. But you do have choices. Again, you may or may not be able to reach the scale. And MQTT, again, has really become the de facto standard for IoT. So when we're seeing cutting edge services being implemented and invented now, MQTT is usually a leading choice there. So let's advance to the next slide here.
See if you did better than I did. While you're doing that, I'll just mention too, an important thing about HTTP is that it requires synchronicity, right? You have to have both endpoints on the network together talking to each other at the same time. And where that's not a constraint for MQTT, right? That's designed around asynchronous communication. So it uses a publish subscribe vocabulary, right? A client can publish information, and then the broker's job is to move that information on to its subscribers, right? Wherever they may be and whenever it is that they join the network, and vice versa. So it supports a very flexible kind of architecture, which you're going to need in an environment where you have vehicles moving in and out of network range, or maybe even in and out of a city entirely, right? Okay.
Thank you. Good points, Josh. And just if you're not familiar with asynchronous communication, it's things like email, right? That don't have to be necessarily directly responded to. And so let's talk about some specific use cases. The first one I'll cover, intelligent traffic management, is more of what we'll see in the future, starting to bring these networks, these systems, this data together, both on the sensor side, bring that data into the cloud. So I'll advance here, and there we go. So this is a wordy slide, so let me walk you through this from left to right. This is when we talk about smart mobility, it is about bringing those systems together and bridging that data. And we definitely believe that MQTT will be that bridge. So here we have three systems: a vehicle telemetry system, bringing in data from the vehicle, a central control system, and a traffic system control. And today, those systems are very much separated. But as we grow, as we pave the way for smart mobility, we'll see data that we're already collecting in a lot of ways start to integrate and start to be used together. And so things like speed, location, even number of passengers in a vehicle can be collected, sent to the cloud, and because that's most likely where that central control system will live. And other things like actually, so we have vehicle to vehicle communication that helps facilitate that, but also vehicle to infrastructure communication, so that we get updates on things like traffic conditions, average speed, and congestion levels, right, which long term will help reroute. And so Josh mentioned that the speed and reliability of MQTT, right? And so we're talking real-time communication. And what does real-time mean? Less than a second. A lot of times we're talking sub-second or millisecond communication. And so that data, that communication, those messages will come into a central control system through the MQTT protocol. And here in the center here, you see our EMQX cluster MQTT broker that's bringing in that data and making it available to your backend systems that you may already use today, like Kafka, SQL databases like MySQL, Redis, different webhooks to tie into other applications or service monitoring platforms. And on the other side here, we have, on the far right, we have our traffic system control. And these are things like stoplights, walk, don't walk signs, and using that data, being able to process that data in real time, we're able to make decisions in near real time and manage those systems more effectively. So could you imagine a system where, based on the congestion, the traffic light changes its timing, right? Or helps to reroute traffic around congestion, around dangerous areas, even around power outages. And we'll talk a little bit more too about not just power management, but EV charging systems and managing those types of mini power grids. So let me advance now to our next use case, which is vehicle to cloud communication. And again, this is an area where MQTT has really shined to be able to bring that telemetry data into the cloud. And we have this year have done several webinars about these types of systems, not only in bringing in information from smart cars, but even in the factories that are building those cars and combining that data to make smart business decisions. And so as a car is moving down the road, it is obviously changing networks a lot. It's changing maybe even the type of network that it's on. And so we are here at EMQ, we are the first to implement MQTT over QUIC. Quick is a protocol that was initially developed by Google, and it works very well over networks or situations where your network is changing. In a previous webinar, our developer advocate, he connected two clients. One was a TCP/IP client, and one was connected over UDP and Quick. And with the network going away, whether it's an IP address change or completely changing the network, the Quick client recovered very well in that it didn't care that the network went away, versus the TCP/IP client. It didn't take it so well. It wanted to reboot, reconnect, reestablish that connection immediately. So you saw a huge decline in the amount of throughput of messages. And so MQTT over Quick is a great solution for that in-vehicle data, to push it out to the cloud. So in this model, you see that the car is, again, it's collecting so much data, and from CAN bus data, it may already be even producing some MQTT messages and may communicate over UDP, and so we have several different types of communication that are coming in. And here, Josh mentioned earlier our what we call ECP, our Edge Cloud Platform. And this is a version of that, and has been very intriguing to a lot of the vehicle manufacturers that we work with, in that we're combining those systems using tools like eKuiper and NanoMQ to bridge that data into MQTT and bring that, communicate again over MQTT to the cloud, to make that data available for your backend systems, whether that's AI modules or AI training, whether you're doing some rule filtering or rule management there, which we also do within our cluster, to make sure that you can effectively get the data that's important to you. And so a big part of these systems is not just that protocol MQTT, but that bridge from the sensors, wherever those sensors are, to the cloud. And I'll mention we do work with every cloud. We're available in every cloud. So whatever cloud you choose, multi-cloud or even private cloud, we can bring in those messages for you. Let me advance here to. So this is actually one of my favorite use cases, and one that when we talked about earlier about smart traffic systems, it is a bit of a stretch in that we aren't implementing those systems in full today, right? We are implementing these systems today. We are powering EV charging systems and EV charging infrastructure, and making them more effective, more reliable, easier to manage. So in this workflow, you'll see on the left, we have different information that's coming in from the vehicle. And it can even be coming in from sensors in the charging units themselves. So you see the communication over MQTT. We also support MQTT SN, which is MQTT for sensor networks, which is even more effective and lightweight. So especially for devices that are battery powered. is a lot of times a good choice for those types of systems where you want to reserve that battery, maybe go to sleep in certain intervals to save battery, to save network bandwidth. And again, the first to implement MQTT over Quick. Very proud of that, and do think that that will continue to be a driver for our platform to power future systems. And so in the center here, you see our EMQX ECP platform, which again is an integration of to help you bring in that data and help you make it easier for you to manage these systems. So it uses our core product, our EMQX broker, and so you get those features that Josh talked about with scalability. We've simulated, connecting 100 million devices. And so our cluster is, even though lightweight, scales really well. And that's when we're talking about IoT data and scaling IoT data and device connectivity. We're very good at that. That's our core. And so you'll see in the center here, us bringing in that data from different devices, from smart cars, and delivering that to, in this example, another technology you may be very familiar with. It's not our technology, but we work very well with Kafka. And so you see that information being delivered to Kafka, and then again, making that data available in the cloud so that you can use systems, big data, relational database systems, Redis, and a lot of the tools that you're already using today, just build on that. And then you see here we have an API gateway, right? Because usually there's some translation that needs to be done on your end to integrate that into, for example, if you have an app, right, or again a service platform that you want to bring that data into, and we have many integrations and many tutorials on our site that will help you connect to these systems. And so before I go a little further, I would like to share with you a recent customer that we worked with that has created a similar system. RavenVolt manages these types of power grids, and we help them by taking that data from their smart charging systems and helping filter that data at scale. One of the reasons they went with us is one, the scale, and secondly, it was so easy for them to implement a system that they could continue to grow their charging infrastructure. So very, very proud and happy to work with them to not just bring in that data, but make their system smart, so we can do things like manage the load, manage the redirect the load in certain areas, whether that's due to demand or even things like bad weather, like hurricanes. They work very well in those inclement weather conditions, being able to reroute power through around areas that are going through hurricane or weather that might disrupt the power grid or power source in some way.
That's a great point. I just wanted to jump in because you made me think of something. For charging infrastructure in particular, as we transition, into more of an electrified transportation system, right? We have to imagine that not only will the number of charging stations need to increase, we'll also see charging in other forms, right? Passive charging embedded in roadways, for example. But the big point that I want to make that I think Ernest is touching on here is that the uptime of those systems is going to be really critical, right? Because they'll be used more frequently, not just from the Tesla owners and like the two guys that have a Nissan Leaf. Everybody's going to need to be charging. And so the ability to monitor that in real time, to be able to detect different kinds of problems and to be able to do that at scale, that's really the kind of application that we're talking about here. And there are systems in place to help with some of that right now, like a charging system management software. There's different platforms out there, certainly. And I think there's a bigger point here too, which is that it's not like we're going to be building these systems out of nothing and then putting them together, right? A lot of systems that already exist will have to be integrated. And so there will need to be different integration points for doing that. So we're certainly not suggesting that MQTT will be the protocol for all of these things, for everything, for all time, but it makes sense to have it at the center of the architecture as a way to facilitate interoperability between all of those different systems. EMQX actually provides a plugin to connect with through OCPP, which is the open charging protocol for charging systems that use that protocol. So you can convert that OCPP data into MQTT, and now it's ready to move into the cloud, facilitating applications like remote monitoring or control of your charging infrastructure, which may not be a feature that's provided out of the box by your sort of standard charging infrastructure monitoring. So that's kind of the architecture that we're talking about here that is going to evolve over time, right? MQTT facilitates the communication between all of those different systems in a way that's scalable and cost effective.
Very well said, Josh. And so to wrap up, that was my final use case. But just to conclude here, we covered a lot, and smart mobility is it's a new and different way of implementing smart cities, smart transport. And so it's exciting to be a part of that growing technology. And so the use cases we covered aren't all inclusive, but hopefully they gave you some ideas about the integration of the different technologies. And as you choose a messaging protocol that's going to help you integrate these siloed systems, then we hope that you choose MQTT, and more so, we hope that you choose EMQ to work with you to help implement those solutions. And so, as the world's number one MQTT broker, we pride ourselves on that development and continued development, continued growth of the product. And so with that, I believe we are in our Q&A section. And
hey, I didn't even need to give you a 5-minute warning. You guys timed that perfectly. Well, I wanted to go ahead and thank you and Ernest and Josh for such an informative discussion today. We did receive some questions, so we'll try to get to them through as many of them as possible. If we don't get through all of them, we will certainly follow up post this event. So feel free between you and Ernest and Josh, I'm sorry, who would like to go ahead and tackle the answer to the question. So first question we have here is, can you support MQTT over TCP, IP, and QUIC simultaneously? And I think, Ernest, this might be a better one for you.
Yes, I can answer that one, and the answer is yes. Typically, what we've seen implemented is you will have both, but if you cannot, you can have two clients, and our developer advocate Mohib demonstrated that those two clients were connected to the same broker. But what will happen is that if you end up dropping that UDP connection for some reason, it will pretty quickly fall back to standard TCP/IP. And so this happens very quickly. And so it's you can use both simultaneously. And if you have clients that are connected over quick, they can fall back to TCP/IP.
Great, thank you. Another question, is MQTT good for sensor data only, or can it be used differently? For example, to transfer commands. What are differences in such cases like transaction support?
I'm
Josh,
not
you want to tackle that
100%
one?
clear on transaction support, what you mean by that, Alexander, but so feel free to clarify in chat if you want to. But yes, the general answer to your question is definitely MQTT is used for other things besides sensor data. And it is definitely used for command and control. As I mentioned, it was originally designed for process control applications, right? And so MQTT is bidirectional. You can bring telemetry data in from the field. You can also send commands back out to those same devices. And MQTT provides full control for, it calls it ACLs, access control lists, but to determine, which clients on the network are able to read and write data to which other clients and so on. So you're able to manage that with a pretty good degree of granularity, but definitely bidirectional. And yeah, use cases for that. I think if we go back to our charging infrastructure use case, is a pretty good one. You might want to, for example, most of the time, right, 80%, 90% of the time, you're just monitoring all of those different charging points. You're looking for them to send out alerts that there was some error in operation, physical damage. Maybe there's a camera that's watching a parking lot, something like that, and you're sending data from that. That's mostly what you're doing. But then when you are at a low traffic time, for example, low utilization time, like in the middle of the night, you might have a charging system monitoring everything that wants to push out a firmware update. So it's going to send out a command to all of those charge points that are going to be impacted and tell them to go into a maintenance mode, for example. And it's going to send out a URL, or maybe in a parallel protocol stream, you're going to send out the actual file data, right? That each of those microcontrollers is going to use to update itself, and then it'll report back when that's completed. And so yes, that's a very common use case for that kind of bidirectional communication. So hopefully that answers that question. And if you're looking for other kinds of applications that are not related to physical devices, we should follow up. We could talk about that, but there are certainly lots of those as well.
Okay, to follow up on that question, do you see using MQTT for inter-process communications on a single host?
I'll jump in and
Yep.
take that one. Well, yes, the answer is yes, but when we think about it, it's more appropriate for the scalability. So we're talking, like, especially in the case of smart mobility, not just the inter-process of that communication within that single host, but again, taking away that silo, so that that host, the information that host is processing is made available. And so when we talk about inter-process communication, a lot of that can be done through a MQTT on the local device. It does have a very small footprint. So yes, if you want to do some filtering on a single host or a single cluster, it can definitely do that. But the benefit is really when you start to scale from hundreds to thousands to hundreds of thousands to millions of devices. That's where it really shines.
I just noticed the last question, we got some clarification on transactional support. So yeah, MQTT, I would say it's not transactional in the same way that transactional, database is, right? But yes, it does facilitate different quality of service levels that basically have a handshake mechanism where that goes back and forth between clients and broker to ensure that messages are delivered, right? The specific concern that we're addressing here is data loss prevention, right? So you can use increasing levels of quality of service built within MQTT that at the cost of some performance, right? By which you can instruct the broker or the client to repeatedly send information until it receives confirmation that it has made it to its destination. Or you can add other levels of quality of service to do both guarantee delivery and reduce the number of messages sent, right, to avoid duplications. And then there are also lots of other levels of data loss prevention that should be built into your broker, right? EMQX supports external data persistence, so you can move session data or message data into a database. In the unlikely circumstance that your entire system crashes and you still need to have that data, or before you roll over to a failover system and you want to be able to restore that data, yeah, that's absolutely something that you should consider, and that's something that is not part of MQTT, right? That's going to be a feature of the broker that is serving all of the MQTT traffic. So hopefully that answers that part of your question too.
Yeah, I'll build on that, Josh, and answer another question, which is, can you recommend a time series database which has support for MQTT out of the box without external components? What I will say is that we don't necessarily recommend a certain database, but I can tell you that our team is very active in helping educate and helping integrate different components in the IoT world. And so we actually produce a blog almost every day. And a lot of these blogs are pretty technical and will give you step-by-step tutorials on how to connect to a lot of popular databases because there's so many. We support so many industries, so many use cases. I'll be remiss to only recognize one database, but there are many that we integrate with.
Yeah, we do have partnerships with InfluxDB and Timescale, which are two very popular time series databases. So I, off the top of my head, I couldn't say what level of native MQTT support they have. I know Canary is another time series database, although it's more geared towards the industrial sector, but that provides its own MQTT connector. But yeah, we have over 40 native integrations that are just included in the EMQX Enterprise product. So yeah, the integration with a time series database shouldn't be a challenge, even if the database of choice for your application maybe doesn't provide a native option.
Yes, and in our latest release, you can actually, we call it our flows. You can actually see in the GUI your relationship and manage that that connection. So again, we make it very easy for you to implement, and we're constantly working on those integrations.
Okay, next question. What is the minimum memory requirement for Nano MQ? How angry Erlang applications in comparison, for example, with Java applications?
I see that one. I'm not sure angry. That's I'm gonna need some clarification on that one. But yeah, Nano MQ has a very small footprint. I think with the minimum feature set is like 200K. So pretty tiny. Which is because it was designed specifically for embedded applications like running on vehicle to serve as a data bridge for those on vehicle systems. But yeah, I'll have to clarify the angry part as that relates to Erlang and Java.
In the interim, let's move on to the next question. Does COAPP also use a publish subscribe model?
Yes, it does,
Oh,
but in a different way. Because with MQTT, you're subscribing to a topic, right? But it's not directly, but it's very similar in that you're subscribing to that REST message. And so again, you can observe to be able to trigger things or filter for certain changes in the rest. So it is different, but it is a very similar model.
yeah, and you'll find publish subscribe type architectures in multiple protocols. That's not unique to MQTT for sure.
Okay. Next question. How do we take advantage of UDP transport when using MQTT? Is there a setting for the broker to switch from TCP to UDP or something else?
That's a good question. So you can take advantage of UDP in a couple different ways with EMQX. I can't speak for other brokers. Ernest, you mentioned earlier support for MQTT SN, which does use UDP as its transport. So that's one way you could do that. Something that is worth touching on, though, maybe more importantly, MQTT over Quick. If you're familiar with the Quick transport protocol, that is actually based on UDP, or it uses UDP as its lowest layer, and then it encapsulates all of the TCP like functions, right? Error correction and whatnot in a higher layer. So you can actually, so if you're using MQTT over Quick, which is a unique feature of EMQX right now, until we get it into the MQTT spec and everybody does it. But for us, for right now, it's just us. That does sit on top of UDP. If that's important for you, yeah, we should talk about application there, because yeah, you may run into other constraints with using UDP over cellular networks and whatnot. So there's some things to be aware of there. But the way that EMQX handles that, maybe Ernest mentioned this earlier, you can instruct the broker to support quick-based connections and then fail over to a TCP-based connection if there's some issue, for example, with UDP being blocked or something like that. So again, that's unique to EMQX, but it is able to handle both of those, either failover between those different transport protocols or a mixture of clients using different transport protocols.
Okay.
Good one.
Next question. With higher data loss prevention, the confirmation comes from the broker. The broker receives messages from the producer. Is it possible to wait for confirmation from a consumer so the producer is notified that all subscribed consumers are confirmed to have received the message?
Yes.
Okay.
Yeah, that's an easy one.
All righty. Looks like we have time for two more questions here. Do we have to create our own plugins to support COAPP and LWM2M?
Oh, great question. Yeah. You want to take that one, Ernest?
Sure. We do have integrations, and again, we have actual tutorials on how to make those connections. But not saying, again, we support many industries, many use cases. So in some cases there may be some modifications that you need to make, but in general to that, the answer is we do work very hard to support those integrations so that you don't have to completely write your own tools. And we do have a pretty robust API that's available if you need to extend the capabilities.
Okay. Well, we are down to the last couple of minutes here. Any final thoughts? Wanted to go ahead and let everyone know, if you have questions post this event, feel free to go ahead and reach out. Happy to go ahead and address those one-on-one. Any final words, Ernest and Josh, before I let us all go for the day?
The future's bright. I'm excited to see this stuff happen, and it is happening. I'm looking at the list of attendees. I think these are mostly folks we haven't talked to before, but I can say that we are talking to companies who are working to solve these problems, right? Both on the automotive side, right? Designing vehicle services, right? Vehicle connectivity to be able to work with this type of infrastructure, as well as telecom companies who are trying to design IoT services to facilitate the needs of, different municipalities that are going to want to roll out these systems. So it is happening. We're seeing the early days of it, and MQTT is already a part of it. So I'm looking forward to what's coming. Ernest, any thoughts?
Well, yes. In closing, I would like to say that I'm very proud to be a part of EMQ and be a part of this industry, and things like our support for Quick and even our ECP platform. So if you didn't already have a reason to reach out with us, look into that, and it just shows our continued commitment to growth and support for the latest solutions, whether that be smart mobility or whatever you can imagine.
Well said. Yeah, if you're at the point of looking to test out some of this stuff, we're happy to help you with that. We provide testing services, and we can hold your hand through that whole process. So, thanks for coming.
Well, thanks again, Josh and Ernest. This does conclude our webinar for today. We will send you all the recording of the session shortly, should you want to go ahead and have a replay. Thanks again for joining us, and have a great rest of your week. Take care.